Hello students, this is Mr. Fugay and welcome to Geometry. Over the course of this semester, we're going to be exploring a lot of things in regards to this course, but to get us started, much like any other place, we need to start at the beginning, at the fundamentals, at the building blocks, at the puzzle pieces that are going to help us build this course. So, we start with what we're going to talk about in this video, which is points and lines. Now, hopefully you have already taken a look at the overview video that I've shared with you from Math Antics. Provides a really good visualization of everything to help connect what we're going to be talking about. My job in this video is to go over the particulars with you and maybe some of the common mistakes students have when labeling and communicating in geometry. So starting right away, we're going to talk about a point. And quite simply, a point is going to just be, well, a dot, a location in space. Well, so we represent it with a dot because otherwise you wouldn't know where it is. So if I'm pointing anywhere in the room and I look at a particular area, I can now identify that, putting a dot there, and then we label it. And that naming rule that we typically do is we would just write point and then whatever the letter we've chosen, or sometimes we could just say the letter. A single letter is going to denote for us a single space, a single place in space. Now, the reason I say that is, as mentioned in the Math Antics video, we don't want to overcomplicate things. Yeah, can you name a point anything you want? Absolutely you can. There's no big rule that's going to break it, but it becomes more complicated, more convoluted, and we don't need to do any of that. So a single letter is preferred. Now, moving on to lines, lines are going to be straight, one-dimensional object, meaning they either go left, right, up, down, diagonally. That's it. There's no curve to them. So they are a straight, and it's one-dimensional, which means it's not going to have any kind of curves to it, and it's made up of an infinite number of points. Now, we're not going to label the infinite number of points. Sometimes we're going to label 2, maybe 3, maybe 0. We'll talk about that in a few seconds. But in this situation, I have labeled 3 points, C, A, and T. Now, when you want to name this line, we're going to use the line symbol, which you'll see on screen in just a second, and we are going to pick any 2 points. So the 2 examples I have here in the notes are CT and CA. So if you label someone and said, hey, look over at line CA, we'll see a C and an A, and we'll extend ourselves to see that we're looking at that. But if you called it CT, we're still talking about the same thing. So as long as you pick any 2 points on the line, you are good to go. Now there is one other thing we need to consider. There will be some diagrams in this course where there will not be any points drawn. In that situation, what we typically will do is towards the side or end where we draw the arrow, because we can't draw a line forever, we draw a little arrow, we're going to have a cursive letter there. In this case, I put an L. I usually use L, M, N. It really doesn't matter. In this case, we would just say line L. And we only really do that when no points are defined. If there are points there and we label them, that's usually 90% of the time how we're going to do it. Now, here are a couple non-examples that I do want to discuss, and I want you to pause this for a second and think about why are these 2 examples not good examples of labeling. So pause the video. If you've already had a chance to pause, let's look at this first one. In this one, I really look at it and I'm like, okay, well, there's a line. There's only 1 point labeled, which is W. So what's wrong with saying W and then having the line symbol up with the double arrow above it? There's nothing wrong with it. The problem here is that even though it's not currently drawn on screen, I could draw other lines that go through W. So for example, if I have all of these black lines that I just drew in, all of those technically could also be considered line W. So I'm not being specific enough. So it's really important that for lines we pick any, which is the nice part, but you have to pick 2 points. And then in the second situation here with NO, if you'll notice, NO is fine. The problem is the symbol. The symbol here, this segment or symbol is actually called the segment symbol, which we're going to go to next. Speaking of which, here is a segment. So if you notice now, the segment is a part of a line, and it has 2 endpoints. And what's really important about line segments when labeling it is we want to denote the beginning and the end. So in this case, this line segment begins at D, ends at G. If you have a different perspective, maybe it starts at G and ends at D. So either of those definitions for a segment are going to be completely fine. Now, I have a couple things I'll write here, but before we do that, here's a couple non-examples that I want you to think about again. Why are these next 2 not going to work? Pause this video again to think about it and press play when you're ready. So this first one, OG, this has the correct symbol above it, okay, a bar symbol. OG means it would infer that we would start at O and end at G. So notice that if I were to say, hey guys, look at segment OG, you would only be looking at this part right here from O to G. So keep that in mind. And then for this one, kind of like the last example, I tricked you. I threw the line symbol up there. So even though DG is correct, the symbol is wrong. So in our naming rules, we must use both endpoints to label. That's like you can't pick any points in this case. Whereas a line you can, segments you can't. And there are the reasons why those non-examples are going to work. All right, we're going to look at 3 more definitions in this first video. So let's go ahead and move on to another type of line, which is called a ray. So the ray is going to combine what we talked about with a line definition with the segment. It's a part of the line that originates at an endpoint, so it has one endpoint, and then goes infinitely in one direction. So a line has infinitely in both directions, segment has 2 endpoints, a ray is a combination of the 2. Now, in this case, my endpoint is G, and it's going to move in the direction of where points I and P are on. So in terms of some labeling technique here, what's really important here is your first point that you label for a ray must be the endpoint. So notice in both of these examples, I have G written first, but then the second point can be any other on the ray. So I think it's a combination of line and segment. Line, you can pick anything you want. Segment, you have to write endpoint. So you write your endpoint first, and then you pick any other point on the ray as your second. And notice the ray symbol has the segment on this side, the arrow on that side. Which brings me to these 3 non-examples that I want to discuss. So for this first one, the issue here is that this first point right here is not the endpoint. So yes, it goes in the direction of P, but it's inferring that it starts here and goes in the direction. In the next one, PG, well, this is written backwards because it looks like it's saying the endpoint is P and it's going in the direction of G. Which brings me to this last non-example, because if you notice, it's also called PG, but did you see how I flipped the symbol? So it almost kind of like would infer that, oh, this G right here is the endpoint, and this P is the direction it goes in. This one's typically frowned upon because general geometric notation is always going to have the endpoint written first and the direction written second. And so there are your 3 reasons why these are non-examples. Okay, so moving down to a ray, what if we have now opposite rays? Well, this is talking about 2 rays that have a common endpoint, but they go in opposite directions. So let me talk about that opposite direction part. So the first thing I'm going to list here is a ray, and this ray begins at point F, goes in the direction of K, and we're good to go. So in order to have an opposite ray to this, they have to have a common endpoint. So I'm going to have to create another ray that starts at F and then goes in the opposite direction. So that's going to look like this. So ray FJ starts at F. You can see the blue there, and it goes in the direction of J. So a quick way to tell if it's going in opposite directions is that when you look at it as a whole, it should just look like a line. Opposite rays, a pair of opposite rays, essentially just creates a line. And so using this, that's what we're going to talk about here, is a quick way for us to verify if this indeed is an opposite ray. Now, in terms of labeling, we would just say in this case, well, FK starts at F, goes to the right. FJ starts at F, goes to the left. Those are considered opposite rays because they both have the endpoint F. And then K and J are collinear. Well, we'll talk about that word in a minute. That's another way of me saying they're on the same line. And so here's a quick non-example. You should hopefully see right away that this doesn't form a line, okay? And the reason why is because it has a bend in it. And we'll talk about that bend creating an angle in the next video. But for now, we would not be able to say they are opposite rays because they're not on the same line. And so for our last definition here, at the end of this, I wrote the word collinear. And this is another term that I use instead of me always saying, hey, they're on the same line. They're on the same line. The quick way to say this, a one-word way to say this, is that they are collinear. A lot of words in math, if you break down the word, kind of tells you the definition. Co usually means together. Linear means line. So it's a term to describe points that lie on the same line, and then it also means or can be drawn on a line. So in this example, I'm going to throw a point W up here because we're going to use this diagram, J, F, K, and W, to help with collinear. So if you notice, J, F, and K are on the same line. It's pretty clear to see, as we talked about with opposite ray, that you can draw a straight line that connects all three of those together. So we would say that is collinear. But here's the other part of this. W and J are actually collinear also. Now, you might say, but wait a second. I don't see a line connecting them. Look at the part in parentheses. Can I draw a line between W and J? And the answer is yes, I can draw a line between these two. So because I can, we can call it also collinear. So it's not just the lines you see, but it's the lines that you can create in that situation. Now, to show an example of what's not going to be collinear, what if I use the letters W, J, and then I throw F into the mix? Well, that's not going to work because in order to draw it, I'd have to connect W and J, but then I'd have to curve my line to get me to F, and that right there is going to be a problem. So that's our first video on points and lines. Our second main video in this lesson is going to talk about angles, which you will be getting to shortly. But for now, this is Mr. Fugay telling you have a good rest of your day, and thank you for watching.